Okay, question 15 of the 2021 Specialist Maths Exam 2 multiple choice. Diagram below shows a stationary body. So this is in equilibrium. Excuse me. It's being acted upon by four forces whose magnitudes are in newtons. The force of magnitude F1 acts opposite to direction of 8 newtons. Find the value of F1. All right. So what I'm going to do is break it down into two parts. So along the direction of F1 and 8, so across the page, left and right, and then perpendicular to that, up and down the page, I'm going to call it. So up and down. So what I'm going to do is split this F2 into two components, that one and that one, and then this 6 also into two components, that one and that one. All right, so I know up and down, I know that this component here of F2 and this here, because it's in equilibrium, they've got a balance. So F2 sine 60 has got to equal 6 sine 30. All right, and so when you do that, F2 times root 3 on 2 equals 6 times a half. Then F2 then, so divides both sides by, well, 6 times half, of course, is 3. Divide both sides by root 3 on 2. Dividing by fraction, turn upside down and multiply. And so you get 6 on root 3. And I'll just leave it at that for the time being. We'll change that if we need to later. All right, left and right. All right, to the left, I've got F1. But I've also got this component of 6, so plus 6 cos 30. And to the right, whoops, not plus, equals, because they're in equilibrium. The 8 plus this component of the F2, which is 6 on root 3, times cos 60. All right, so what do we got? We've got F1 plus 6 cos 30, 6 times root 3 on 2. There's a cancelling there, equals 8 plus 6 on root 3 times cos 60. There's a cancelling there. All right, so then what do we got? We've got then that F1 equals 8 plus 3 on root 3. I need to rationalise that now. Minus this stuff here, which is 3 root 3. All right, so 8, what do we got there? 3 root 3 on 3, which is just root 3, minus 3 root 3, which then would be 8 minus 2 root 3. 8 minus 2 root 3 is A. All right, so key there is that it's stationary, so it's in equilibrium, and so I've resolved in a couple of directions. There would be other ways of doing that, but that's the way I've chosen. All right, 15, 16 we're up to now. So an object of mass slides down a slope. All right, so it's going to be tricky. So it slides down a slope angle theta to the horizontal. So here's our thing, there's theta, there's our box, there's our weight force down there. Okay. So there's what we've got. So the acceleration is A. So let's have a look and see from that. So for this one here, that's theta up in there. That's mg sine theta. And so mg, the force acting on it, is mg sine theta. And that equals to the mass times the acceleration. Masses cancel. So in terms of this first one, the acceleration is g sine theta. So sine theta is A on G. All right, so that's the first part. So I've just looked at these first two lines. The angle of inclination is now doubled, so we're now bringing this up to 2 theta. Then the acceleration is what? All right, so if I'm looking at the same thing, let's just look at the acceleration. I'll give that a 1 there. So the acceleration of this second one then, well, that's still mg, but it's sine 2 theta this time, because that angle is 2 theta now. All right, so the force down the plane is mg sine 2 theta equals ma2, so the acceleration now, the mass cancels, so the acceleration now is g sine 2 theta. All right, so we need to know this sine 2 theta part. And sine 2 theta would be g, using a double angle formula, 2 sine theta cos theta. Now we've got a value for cos theta here. It's our original acceleration times g, over g I should say. We need a cos. So cos theta, of course, is 1 minus sine squared, the square root of. All right, which is the square root of 1 minus a squared on g squared. Which can, if we do a common denominator here of g squared, you get g squared minus a squared all over g. All right, so we've got g times 2a on g times the square root of g squared minus a squared all over g. We've got a g up there and a g there that can cancel for us. And so when we multiply these two with these things together, we've got 2a on g. So a2 is 2a on g times the square root of g squared minus a squared. All right, so we're looking at which one is that. That is B. All right, so getting towards the end, so they're getting a bit more involved here. Question 16. All right, question 17. Bottles of a particular brand of soft drink are labelled as having a volume of 1.25 litres. Machines filling the bottles deliver normally distributed with a mean of 126 litres and a standard deviation of 0.01. The probability that 6 bottles have a mean volume that is at least the labelled volume of 1.25 is closest to. All right, 6 bottles, so that's N. So we're taking a sample here, so the probability of the sample. So the probability expected value of the sample volume, we take our sample mean, it's the same as our population mean. Our standard deviation of our sample is our population standard deviation divided by the square root of n. All right, and now what we're looking for then is that the probability of our sample volume being greater than or equal to 1.25, oops, 1.25, not 1.6, 1.25. And so what we now need to do is we need to go to our calculator and see what we can get here. There's our calculator. We need to go to our interactive, our distributions, our continuous, our normal CDF, and we need to go from there. So our lower value, 1.25, our upper value, whatever, our standard deviation. So our standard deviation will be, oops, now standard deviation will be 0.01 divided by the square root of 6, and our mean is the 1.26. Sorry, you can't see my head there because I'm working on my calculator. And there we are, 0.992847. So 0.9928 is what we're looking at. So 9928 E. All right, so that will do us for this video.